Hi, here we're going to look at how to work out the area and perimeter of sectors of circles. So first, to recap, for GCSE exams you need to remember the formula for the area and circumference. For that we have these sort of two phrases, rhymes, whatever. Cherry pie delicious, that tells you the circumference equals pi times the diameter. And then for the area we have apple pie is a square, that tells us the area equals pi r squared. So pi's r squared gives you pi r squared. So basic example of the area and circumference of these two circles. So here for the area, I would do pi r squared, which would become pi times 5 squared, because that's the radius. For the circumference you would need the diameter. That diameter is going to be the whole way across this circle, which would be 10 centimeters, because it's double the radius. So therefore you would do pi times 10. And again, get a calculator, work those both out, it'll do it all for you. For this example, we have the diameter, but we would need the radius here, which would be half the diameter, which is only 9. So for the area, you would do pi r squared, which is pi times 9 squared. For the circumference, you would do pi times diameter, which is pi times 18. That's the basics, which we should be fine with. So main questions are for areas of sectors. That's basically part of a circle. What you would do, you'd first work out the area of a full circle, as if it was a full circle, and then you would times by what fraction of the circle you have. In order to find the length of an arc, you would do the exact same. You would do the circumference for a full circle, and you would then again times by what fraction of the circle you do have. Let's first go through a few examples of that. So I want the area of the sector and the arc length. So area of the sector is this area here. So for a full circle, we would do pi r squared. In this case, 8 is the diameter, so 4 would be the radius. I would then times by what fraction of a circle I've got. I've got half a circle, so therefore I must halve my answer. To work this out, we can just go to our calculator, do pi times 4 squared times by a half, which gives you 8 pi. If you want it in terms of pi, otherwise it is 25.1. So that was the area. For the circumference, we want pi times diameter. So in this case the diameter is 8 and we're given it. And again, because we've only got half a circle, we times this by a half. So you get your calculator and do pi times 8 times a half, which gives us 12.6 to three significant figures. Okay, slightly more involved. Here we don't have an obvious fraction of a circle, instead we're told it's 40 degrees. So I just want the area here. So we're going to do pi r squared and then times by what fraction we've got. We can work out the fraction by how many degrees we have. We've got 40 degrees, and we know in a full circle there are 360 degrees. So that is what fraction of a circle I have. We then plug the rest in. We do pi times 7 squared times 40 over 360. And then that's us done with the hard work. We now just pass it on to our calculator, who will do the rest for us. Okay, and that gives us 17.1 to three significant figures. Okay, slightly harder. We want the perimeter of this sector. So previously, if I skip up a couple of slides, we worked out the arc length. The arc length is only this length here. If I wanted the perimeter of this shape, I would have to add on another 8 for this length here. Here we just straight run the perimeter. So what I need to do, I need to work out this arc length and then add on these two lengths, which I can see they're both going to be 10. They're always going to both be the same because they're both radiuses of a circle. So first the arc length, we need to find the circumference for the circle. So the circumference would be pi times the diameter, and then times by what fraction of a circle we have. In this case, we've got the radius is 10, which means the diameter must be 20. And we already know this fraction. So that will give me this arc length. Let's work that out. So pi times 20 times the fraction of 135 over 360 gives us 23.6. Then I have to add on the two tens for this length and this length. So therefore the total perimeter is going to be 43.6. Okay, on to more exam style questions. Here on the end perimeter is compound shape. So this shape you're typically told is made of a rectangle and 1/4 of a circle. So we're going to break it down. First we're going to work out the area of the rectangle. In order to do that, I'm going to need this length here. We can work that out because we're told that this length is 4 over here, and we know for any bit of a circle, all the lengths are going to be the same. So this is also 4, which means that this length must be 10. So this rectangle will be 10 times 4, which gives us 40 centimeters squared. I'm doing the area first, by the way. I now need to work out the area of my quarter circle. So I'm going to do pi r squared and then times by 1/4. So I just do pi times 4 squared times 1/4. Go to my calculator and we can work that out. Pi times 4 squared times 1/4. That gives us 4 pi, which is 12.6. So the total area is these two added together, which is 52.6 centimeters squared. Let's quickly try and do the perimeter as well. So for the perimeter, I need to add together these three lengths, and then I also need to work out this arc length here. So let's try and do that. So these three lengths are easy. These three bits in total will be 14 plus 4 plus 10, which is 28. I then need my arc length, and that's again, it's going to be 1/4 of a circle. So I do pi times diameter. Here the radius is 4, the diameter is 8, and then I times it by 1/4 because I have 1/4 of a circle. Type it in your calculator, that will give you 2 pi, which is 6.28. So for your overall perimeter, you add these two together, which will give you 34.28. And again, that is in centimeters. Okay, I'll just go through one more slightly hard example. So here I want the perimeter of this shape made from two identical sectors. So I need to work out this length, and also these two bits here. So let's go through that. First, let's work out one of these sectors. I want the length, so it's going to be pi times the diameter. Here this radius is 4, the diameter is 8, and I have this fraction of a circle. I also know I have two of these, so I can times the whole thing by 2. So let's go to my calculator, do that for us. So 2 times pi times 8 times 140 over 360. That gives my two sectors at being, I'll include a fair bit, so the three different figures, sorry, that would just be 20.0. I then need to add on my two lengths here and here, so plus on the two 4s, that gives me a total perimeter of this thing of 28.0. Again, if it's three significant figures, you have to include the 0.0 to say you know that third significant figure is a 0. Last question, our tortoise won't quite finish it. Here you want the area of the shaded region. So you basically have like part of a donut shape, where one circle is cut out of another. What you would do here, you would have to work out the big circle, take away the small circle. So I'd include an angle here. This angle is 140. So for the big circle, you would do pi times 8 squared times by the fraction. For the small circle, you would do pi times 3 squared times 140 over 360. For this question, be careful. You can't just take away the 8 and the 3 to give you 5. That won't work. That won't be the same answer. So you have to work it out as two separate parts of the circle and then take them away. Okay, I hope that helped, and thanks for listening.